Hello young scientists, welcome to this unique session. Why unique? Because we will not be using material supplied or given by somebody to you. You will be using material very much available at your home. And we can understand by this that science activities can be done with the material just available around you. And that's a big revelation. So we'll be using these coins today to do multiple activities. And it's very cool. You will understand that science can be done with coins. So many concepts together, but all with coins. So let us get ready to see these exciting experiments today. And of course you will do them independently and understand a lot of concepts. Let us do them. Students, I have taken multiple coins in this. You know, the very easy thing one can do is toss the coin and ask a friend heads or tail. Now that has a possibility of 50% success because your friend may tell heads and it may turn out to be heads, or he may fail and it may turn out to be tails. So this has only two possibilities. If I do it for say 100 times, then half the time it will be heads, half the time it should be tails. Because it has only two possibilities, so half they'll come. However, sometimes somebody is lucky and you succeed in guessing it maybe for 60 times out of 100. It should be 50 each time. You should succeed for 50 times, you should fail for 50 times. But sometimes it happens. But if you keep doing it for several number, 100, 200, 300, 400, you will find it comes to 50-50 in all your attempts together. That is, this is called as probability distribution. There are only two possibilities. So there are 50-50% distribution. There should be 50-50% distribution of two possibilities. That is probability. Now we will do it. Instead of tossing the coins, I am just mixing them. Put them on surface, spread them, and just count how many heads and how many tails. You have to just spread them. Whatever they have come up, you have to spread them. And then start picking up which are heads and which are tails. So there will be two. So I separated them almost, and just start counting them. It will be a fun for all of you that if you do it for 3, 4, 5 times, or if you have more number of coins like I do have, I have so many coins in front of me, then the answer will be always almost 50-50%. So if there are 300 coins, then 150 heads, 150 tails. If you have only 50 coins, do it for 6, 7, 8, 10 number of times and write them down in your notebook. You will find that always it comes to close to 50%, close to 50-50. So like heads, count them, keep them apart, rest of would be tails. So that's the first exercise to understand this distribution. That is called as probability distribution. This time I am doing activity using these 10 rupee coins. So I am just stacking them up. Why 10 rupee coins? Simply because they are heaviest of all coins. So I am just placing a stack of so many of them. Maybe 10 or 12 or plus. I will be using one more and hitting onto this. So will the tower of these coins topple, collapse, or will the coins get disturbed? What will happen? Let us take a look. So only one came off. Again, I'll just repeat this. Again one came off. So you keep trying, you will find always one comes off. So only one gets hit. So that displaces or that goes off. But other coins which are heavy, they don't want to change their place. So they just once again sit on the same place. So one flies off from the bottom and others they maintain their place. This is nothing but law of inertia. You will learn it maybe in some higher grade. Law of inertia or Newton's first law of motion. But is it not fun just to take out one? So continuing with Newton's law, we'll be demonstrating or I'll be showing you one more activity. I'm using all 5 identical coins. They are all 2 rupee coins and of same mass or same weight. Even one more coin or another coin also with same 2 rupee each. So I'll do one thing. I have kept 5 of them in one line, touching each other, and a straight line. In the same line, I'll just take it little away and hit it like a carom striker. And you will find that what happens. Let us take a look. Only one flies off. So 5 were there. One hit the chain of 5 and the last one was pushed off. Let us try to do similar activity using now 2 such coins. I am using 2 coins on one side. They should be just in one line. So let us once again do it and hit it like this. So let's see what happens. 2 of them, they were pushed away. So 2 were to hit the sequence of 5 or chain of 5. 2 were pushed off. This is because their mass is identical. The force applied transfers through these coins and then final same force is in effect produces the result and 2 are pushed off. You can try it even with 3 but I will not show it. So with single one was just it flew off. With 2 were gone. So that is nothing but again Newton's law, that is conservation of momentum. Again, not for your age but just to know that coins can prove so many Newtonian laws like this. We used some 7 coins in last activity. 5 were together in one chain and we were hitting using other 2. This time I am using 3 coins. All 3 are identical. But this time, see, there is some very important difference. Last time the force and this motion of a coin was hitting and they were also triggered. The motion was induced in them and some coin or one coin flew off. This time I am going to press it hard. This is touching it. So this is not going to move. Will this go then? What will happen? Let us guess. I am just holding it this way and just hitting it. So you will find this does not move. But the other one definitely moved and it went quite away. I am just showing again. So it just went down. That means even the middle one did not move its place. The force which are applied on this was transferred to the next coin. This is a shock wave transfer. There are shock waves created in this coin which give that energy to the next coin and that moves. So you don't have to move every object to transfer the motion. You have just seen that motion is transferred without movement of this middle coin. Again, something to do with Newtonian physics. You must have heard of name of Newton. So Isaac Newton, he proved so many such things, but we are trying such experiments, same experiments using coins. Now let's go to some very different concept. Now I'll show you a video of use of coins in concept of levers. Lever is something which is balanced on two sides. You know, like even a balance in a grocer shop that has concept of levers. We'll be trying balancing coins on two sides of lever made at home. So see the video, watch it carefully and try to do these experiments independently at your own place. Hello friends, today we will be doing one activity with very simple material. Many of you might be having it at home. Take a look first. I'll be using this long meter scale. This has centimeters marked on this side, and we'll be using these coins which are absolutely identical. They are 1 rupee coins. So using these two simple things, we'll plan out one activity. Take a look. Look at the setup now. We have created one support, and on that support this meter scale is placed with its center resting on that support. That support is typically called as fulcrum. Take a look. This is 50 and the scale is exactly balanced on two sides. We have to balance coins on both the sides. So I am placing one coin on 90 on this side. That means it is 40 centimeter on one arm. I have to use two coins on the other side to balance this single coin. Let me place them. I have balanced one coin on one side with two coins on the other side, but the placement is very important here. The single coin is at 40 centimeters away from center, and two coins I am placing about 30 centimeters from the center. 20 centimeters from the center, not 30. So I am using 3 coins on one side of the pan and a single coin in the same place. Now what do you think? Where should I place these 3 coins so that this meter scale is balanced on fulcrum? See, I have placed a candle in front of me, that is a burning candle, and of course this cotton thread. You know, cotton thread burns quickly if it comes into the flame. Take a look. So it catches fire. So I am just turning it off. Now it did not take even a second to catch fire. This is cotton. Now I have tied same cotton thread to a coin. I'm just holding it in front of, on the top of this flame. Let us see if it burns. So it took quite long time for this to burn. So quickly it does not burn, it takes some time. Now what happens exactly in this? The heat which is given to this thread is also given to this coin, and heat of that flame gets transferred inside this metal. This metal is a good conductor of heat. So that much of heat is not generated sufficient to set it on fire, set the cotton on fire. It takes some more time to create that much of heat so that this burns. So in this activity, I am using this cloth hanger. This is not steel. It is not getting attracted towards magnet. It must be some aluminum alloy. I'll be making 3 spots or dabs here using this cheese. You can use even butter. Anything is fine. Make 3 such spots. Place some cheese here at spot number 1, spot number 2 and spot number 3. I am placing some distance between them. Okay, I have done this. We will place 3 coins onto these spots of your butter or anything like cheese or butter. Once it is done, let us start heating this from one side. So we have placed 3 coins on this. I'm just holding it on flame. That heat will transfer by conduction because it's a metal and metal conducts heat. So the first one fell down. As the heat transfers, this cheese will melt. And melting of cheese can then make this coin fell. The first one fell quite quickly. We are waiting for next to fall anytime. You can see here this is now totally melting. So it has transferred up to here. Still it is not progressing further. Aluminium is good conductor of heat. That's the reason we have chosen aluminum hanger in place of steel hanger here. Still it is taking some time. I'll just tilt it a little bit so it will help. Yeah, the second fell off. And the third fell off. So sequentially you will find the heat is transferring. This is quite hot now here. Much hotter here. So again we have seen that heat transfers through metal and the coins fell one after another. For this activity, I need a coin, any coin. I am just placing it here. That can be visible from this camera. I am placing on top of this a glass. Still you can find that coin is visible. Now I will take some water and start adding it into this glass. I think still it will be visible. That coin can still be seen inside the glass. If I add some more water, slowly you will find it becomes just a shiny surface and the coin totally disappears. So the bending of rays and internal reflection of light, these are the things which are responsible for disappearance of the coin. However, these concepts are not something in your syllabus or not meant for your age, but you can enjoy just as a fun that how coin, though it is there, but when you place a glass on top of it and fill water into this, it disappears. And then if you keep filling it further, it still continues to disappear. I mean, it doesn't show up again. So that's the way you can make coin disappear by just adding water into the glass. So students, for this activity, I am taking some water in this glass. Let me fill it further So this glass is totally full. So you can see that I have filled this glass completely. There is no scope of filling water any further. Now, in spite of this glass being totally full, can I add some coins into this? And water doesn't spill, of course. Let me start trying one by one. Let the glass get stable. And I'll add one coin. It went in. 2. It went in. 3. Went in. 4. I'll just take the coins in my hand because yeah, let this stabilize again. For you, 6, 7, 8, still water is not spilling. 9, 10, 11, 12, still water is not spilling out. 13, 14. So we can see that still the plate is dry. 15, 16, and one more in my hand. 17. Still water is not spilling. We'll try with 3 more. 18. Now it is on verge of spilling. 19. And now I think water is about to come out. And last I'm trying to add 20. Yes, now water is clearly coming out. So, but still I could add almost 19 to 20 coins when we felt that glass was full. Now water is forming a kind of circular dome shape on top of this surface. So that is because water has surface tension and it holds all molecules together. It does not let them go away or spill off. So it forms a dome structure on top of it. That makes it possible to add more and more coins into even when we feel that glass is full. We have seen different small activities using coins. In every activity there were coins used, and you have seen several science concepts learned using coins. In next 2 activities, again there will be use of coins, but they are not just activities. They are the challenges you can pose to your friends. You know the trick. So ask them to do that activity. If they can do, fine. If they cannot, then you can definitely show. So take a look at these activities carefully. Just do them repeatedly. Be confident to do them and then pose them as challenges to your friends. So take a look. So it's a time to know some challenges that you can pose to your friends and see if they can do it. See, the first thing is dropping the coin into this glass. How? Take any such card sheet, place on top of glass like this. You can find there is a gap kept here. I am placing this card with a gap here and I am placing coin nearby. Ask your friend to drop this coin into the glass by blowing it, of course. Child may start doing it and start blowing it this way. coin won't move. But you can do it if you know the trick. What is the trick? Just turn it towards you and through this gap blow hard just once. Again I am repeating, you have to blow hard through this gap once and see if it drops. So the coin dropped into the glass and this just went off. You are using pressure of air. When you push inside, it creates extra pressure to air and that makes that card just flip like this, and coin being close to this edge falls into the glass. So this is trick number 1. I am using one more trick. See, what I have done is, you can take any card sheet. I have foam sheet, so I have used foam sheet. You can even use wood instead of this. Just insert 4 pins in 4 corners. So this becomes a stand. Place any coin on top of this. So I place this on top of this. You have to make it topple. You have to make this support base topple, or this stool topple, and coin to fell. So you can start blowing. Again you have to use blowing technique. It cannot easily topple like this, because when you try to press air onto them, or these 4 pins do not create that resistance, and so it won't topple like this. So there is a trick for this. Look, what I am doing is bring it towards the face, towards you. Let you rest your chin on this surface and bring it little close, and you can see that stand flew off and coin just dropped.